Okay, so today we're going to talk about piecewise functions. As the name suggests, a piecewise function is a function composed of multiple pieces. Okay? Each of those pieces is a function, and those functions are restricted to specific domains. Okay? So a piecewise function is multiple functions put together that are restricted to specific domains. So the really important key word here is that they are always called piecewise functions. Okay? They are piecewise functions, and it's always a function. So when you get done graphing your piecewise graph, it must be a function. Okay? So at the end, before you finish a graph on your homework or on a test or a quiz, I want you to check that it is a function, okay, which we can do using the vertical line test. All right? You've seen now you should have seen one example of a piecewise function. On your after party, there's an introduction to piecewise functions. That is a piecewise function on the front of your after party. Okay? It's helping guide you in to writing equations of piecewise, which we'll do tomorrow. If you have no idea what I'm talking about, you should, because this is the after party that's due in 2 days. Okay? Okay, so let's look at what a piecewise function looks like. Okay, it's a function, so it's going to start with f of x. Okay? Then you're going to have a curly bracket, and notice there's just a bracket as it opens, not as it closes. Okay? It's just an open to kind of group them together. Okay? So what this says is that f of x equals 5 for all x values greater than or equal to 1, and f of x equals negative 2 for x values less than 1. So what's listed first are the functions. Those are what we're graphing. And this part, what's listed second, those are your domains. So what does the graph of f of x equal 5 look like? No. It's a horizontal line at 5. Okay? When your y is equal to 5, that means all the y values have to be equal to 5. So it's a horizontal line. No, I said f of x. Okay? So I know I'm going to have two horizontal lines, a horizontal line at 5 and a horizontal line at negative 2. This tells me which part of my excuse me. This tells me which part of my graph each of the functions is defined on. So I like to start with the first function. Okay? So I know that f of x is equal to 5 for all x values greater than or equal to 1. So I'm only concerned with these x values over here. So what I would like to do is kind of, in a way, cover up any x values that I'm not concerned with. Okay? So kind of sprawled along the desks, or maybe at the end there are these little cards. Okay? And if you would like to use them to physically cover up your graph at times so that you're only graphing where you're supposed to, feel free. Okay? I have more if you need more. But what I would do is kind of visualize or for real cover up anything that's not x greater than or equal to 1. No, because negative 1, x less than 1 is going to be included in your graph just with a different function. Okay? So let's start here. If I plug in 1 to the equation f of x equals 5, what is my y value? 5. Yeah, because the y value is always 5. So at x equals 1, I have a y value of 5. Do you think that's going to be an open dot, an open point, or a closed point? Closed. How do you know? Yeah, because it's equal to, because 1 is a part of that domain. All right? Now, this function is defined for x values greater than or equal to 1. So which way does my arrow go for my horizontal line? To the right. Okay? So that represents the fact that f of x equals 5 for x values greater than or equal to 1. Okay? So the idea of like covering up the other side is just so you're not tempted to draw your horizontal line this way. Okay? If it's covered up, you know it's going to have to go that way. So now switch and cover the other side of the graph, because now we're only concerned with x values less than 1. F of x is equal to negative 2 for x values less than 1. So start by plugging in 1. When I plug in 1 to f of x equals negative 2, what do I get? Negative 2. What kind of circle point? Open. Okay, now this is the side that's covered because I'm only concerned with x less than 1. So which way do I go? The left. I'm sorry, I didn't understand your question. No, just because it happens to be a horizontal line. All right? So the first thing I check is this a function? Yeah, it is. This open, this closed on top of this open still keeps it a function, because at x equals 1, there's only one y value. What is that y value? At 5. Okay. The bottom ray is open because at 1, notice 1 is not part of your domain of the bottom function. It's for all x values less than 1. Right, not equal to. Other questions? Okay, so this is a function. This is a piecewise function. So is this continuous or discontinuous? Which one? Discontinuous. Why? Good, because you have to pick up your pencil in order to draw it. You have to pick up your pencil in order to draw it. What is the domain of this function? Yeah. Why don't I have to jump over 1? Yeah, it is included up here, even though it's not included down here. All right? What is the range of this function? Yeah. So I think a lot of you guys said this, but it's not negative 2 to 5, right? It's just negative 2 and 5. The way we notate that it's just a single list of or a finite list of values is with our curly brackets. Okay? Remember that those curly brackets represent it's a finite list, and those are the only two values that work. Yes?
Okay, say that the line on the bottom, what if it like went at an angle down? What would the range be?
Well, then we would write the interval of that part of the range.
Would you write negative infinity, negative 2?
Union 5 with the curly bracket. Yeah.
Are we going to always write this as interval?
You could be right. You could, unless it specifies, you could use set notation or something like that. I just always write interval because to me it's easiest. Okay. When x equals 1, what is f of x? 5. When f of x equals negative 2, what is x? When f of x equals negative 2, what is x? Everything less than 1. F of x equals negative 2 for this whole part of the graph, right? Because f of x is my y, so y is negative 2 happens for this whole part of my graph. These are all have y values of negative 2. So it's for everything from negative infinity to 1. Okay? All right. Piecewise functions can have as many different pieces as we want them to. So this next one's going to have 3 pieces. F of x equals 2 for x values less than negative 3. F of x equals 5 for x values between negative 3 and 6. And f of x equals 8 for x values greater than or equal to 6. So again, what is each piece of this piecewise going to look like? What kind of line? A horizontal line, because we just have y equals a number. So this is going to be 3 pieces of a horizontal line. Or sorry, 3 pieces of horizontal lines. They're going to be different ones. So I like to start with the topmost equation. That's just what comes natural to me. So the first value that I'm going to plug in is going to be -3. When I plug in -3 to y equals 2, what do I get? 2. Always going to be 2. And what kind of point do I have? Open or closed? Open. Now, if we were covering up our graph, oh, sorry. Thank you. If we were covering up our graph so that we could make sure we graph in the correct place, everything that is not less than -3 should be covered. So all okay, so all of this would be covered. Which way does my line go? To the left, because it's x less than -3. Reese? Well, when I plug in -3, I know that the y value is 2. So I have a point at -3, 2. All right. Now I want the piece of the function that's between -3 and 6. So you could cover up anything that is not greater than -3 and less than 6. So you would have kind of covers on each side of your graph. I'm saying if you want to use the little things to cover it up so you're only graphing in the right area, you're going to use your x values and cover up anything that is not greater than or equal to -3 and less than 6. Okay, so when I plug in -3 to this equation, what do I get out? 5. So at -3, 5, what kind of circle do I have? What kind of point? Closed, because it's equal to -3. Then plug in your end point, because this has 2 critical values. When I plug in 6, what do I get? Okay, what's the y value? 5. So 1, 2, 3, 5, 6. 1, 2, 3, 4. And it is open. And it's a horizontal line. All right, now we want to go to the third equation. F of x equals 8 for x values greater than or equal to 6. So when I plug in 6 to this equation, what do I get? 8. Open or closed point at 6, 8. And it's for x values greater than or equal to 6. So it goes to the right. Please make sure on the pieces of the functions that continue forever that you have arrows. You've got to have arrows signifying that it goes on forever and ever in that direction. Okay? Is this a function? Yes. Is this a continuous or a discontinuous function? Discontinuous. Good. Now, just because the examples that we're looking at happen to be discontinuous, piecewise functions can be continuous. Okay? They can match up right next to each other. All right? What is the domain of this function? Good. What is the range? 2, 5, and 8. And what do I put around them? Squiggly brackets. All right. When f of x equals -5, what does x equal? Yeah. Does f of x ever equal -5? No. So since f of x never equals negative 5, there's no x value that will cause the function to be negative 5. So you could write that x value does not exist. You could write no solution. You could write undefined. Any of those would be fine. Because that everything from negative infinity to negative 3 has a y value of 2. Okay? All right. When x is equal to negative 3, what is f of x? When x is equal to negative 3, what is f of x? 5. There's an open circle at 2 and a closed circle at 5, so it's got to be 5. If f of x equals 2, what are my x values? Very good. When f of x equals 5, what does x equal? Very good. What questions do you have? Matthew? Okay, so when f of x is 2, that means when my y value is 2, what are my x values? So my y value is 2 for this whole section of my graph. So it's all of these x values. Okay, Blake?
Yeah, for that one, could you just write x squared over 2 instead of x equals that?
I'm sorry?
For the f of x equals 2, at the top it says...
Yeah, you don't have to be using interval notation here. Okay? All right. So let's kind of push beyond the world of horizontal lines, and let's graph a more challenging function. So go ahead and copy this down. Okay, so we have f of x equals 2x plus 1 for x values less than negative 1, and f of x equals x squared minus 4 for x values greater than or equal to negative 1. So if I'm looking at my top function, f of x equals 2x plus 1, what kind of graph is that going to be? What's the shape of that piece? It's going to be linear, okay? Look at the second piece, x squared minus 4. What's the shape of that piece going to be? Quadratic or a parabola, okay? So I've got it in my head what shape both of them are going to be. Now I just got to figure out where they go. All right, so what I would probably recommend is as we figure out how to fill in this graph, you might want to be writing down our steps in order so that when you get home to do your homework, you know where these points and graphs came from. So I like to start with the first equation. So I'm going to start with f of x equals 2x plus 1. And I know that that's defined for x is less than negative 1. So I'm going to cover anything that's not less than negative 1. I would cover with my piece of cardstock this section over here. All right. The first point I would plug in, the first x value I would plug in is negative 1. The value where our domains split are called our critical values. That's always the first point I'm going to plug in. So when I plug in negative 1 to my equation, I'm going to plug it in right here. 2 times negative 1. Okay, negative 2 plus 1. Negative 1. So I have a point at negative 1 and a y value of negative 1. Is that open or closed? Open. Okay, now I need to continue this part of the graph for x values less than negative 1, so I'm over here somewhere. I have a slope of 2 to help me out. What does a slope of 2 mean? Yeah, it could go up 2 to the right 1, but is that part of my domain? No, so I got to go the other way. Down 2, left 1. Yeah. Those are all closed. Make sure you put an arrow to represent that that goes on forever as long as the x values are less than -1. Reese? This value right here, these are called our critical values. Wherever your domain split is our critical values. Okay, everyone okay with this piece? Yes. Okay, so now cover up the left side of the graph because we're going to switch to the other function. Now I want to deal with x squared minus 4 for x values greater than or equal to -1. So again, the first value I'm going to plug in is -1. So -1 squared. 1. 1 minus 3, or 1 minus 4, -3. So at 1, -3, what kind of point do I have? Closed. Okay. I know it's going to fill in this part somewhere. Is this probably going to open up or down? Up. So it's going to go like this, but let's figure out where that vertex is. So you have a couple options from here. You can just plug in values. Okay? You could plug in 0, 1, 2, and figure out your shape. Or you can look at this and remember, what does this -4 do to my parent function? Down 4. So my vertex goes from being at 0, 0 to being at 0, -4. So there's my vertex. But could you have just plugged in 0 and also gotten that value? Yeah. Not -4 because -4 is not part of our domain. Okay. So here's this. This is my vertex. So don't I also have a mirror point over here? Yes. And I can go ahead and graph my parabola. Yep, because it's only defined for x values greater than or equal to -1. That's why I recommend kind of covering up the other side of the graph so that you know where you can graph it. I think you need at least 3 to 5 for a parabola. Okay? All right. Is this a function? Yes. Is this a continuous or a discontinuous function? Discontinuous. But could we have a continuous function? Yeah, if these 2 points matched up, then we would have a continuous function. Okay, what's the domain? Good, and what is the range? Yeah, but you either need to write it in set notation or interval notation. Wait, negative infinity to what, guys? Okay. No. It just happens to be in our situations. No, but if this were for x values less than -1, this is for x values greater than 2, we would have a gap in our x values. So we'd have to take that into account. I don't think I understand what you're asking.
Like if you made a segment, it wouldn't like have a domain of all the numbers.
What do you mean by a segment?
Like a fourth here and a fourth here, it's not like domain shared.
Yes, correct. That would not have a domain of all real numbers. Okay, what is f of 0? -4. When f of x equals -3, what does x equal? No. When f of x equals -3, what does x equal? Yeah, all of these guys. -2, -1, and 1. When x is equal to -1, what is f of x? -3. Okay? All right, one more. f of x is equal to 3x plus 8 for xy is less than negative 3. Negative 2x for xy is between negative 3 and 1. And the opposite of x minus 2 squared minus 3. What's the top function's shape going to be when we graph it? Linear. What about the second one? Linear. And the third? A parabola. And which way is that parabola going to open? Down. Okay. So I like to start with my first equation. My first value to plug in is my critical value of negative 3. So I'm going to plug in negative 3 here. Negative 3 times, 3 times negative 3, negative 9 plus 8, negative 1. So at negative 3, negative 1, what kind of point do I have? Open. Good. What am I going to use to continue that part of the graph? What's helpful with a linear function? The slope. What's my slope? 3. So for 3, I could go up 3 over 1. Am I allowed to do that?
Yes. Yeah. No, because it's less than negative.
Good. It's less than negative 3. So I have to go down 3 over 1. If you didn't remember this, could you just plug in negative 4 and negative 5?
Yes.
Sure. You can always plug in points. Don't forget to put an arrow on your graph if it continues on. But only put an arrow where it belongs. Okay? Everyone okay with that piece? Okay. Let's look at this middle piece now. So if you've liked covering up your graphs, now you're going to cover up anything less than negative 3 or anything greater than 1. Because we're only graphing in a middle section between negative 3 and 1. So start by plugging in your critical value. Negative 2 times negative 3, positive 6. Open or closed? Okay. Now, this piece of the graph has 2 critical values, right? Negative 3 and 1. So plug in your second critical value. When I plug in 1 here, negative 2 times 1, what do I get? Negative 2. Open or closed? Open. What's the slope that should be used to connect these two? Negative 2. So down to left to left. Are there any arrows on that piece? No, there can't be. All right, now let's graph our last piece. What's the first value I'm going to plug in? 1. All right, so let's plug in 1 right here. 1 minus 2. Okay, negative 1 squared. 1, the opposite of 1. Negative 1 minus 3. Negative 4. All right, so at 1, I have a negative 4. Open or closed point? Okay. I know this parabola opens down. You guys already told me that because of this negative. But I got to figure out where the vertex is. Okay? So I could start plugging in values and try and figure out where the vertex is. Or I can use transformations. The negative flipped it. What does that minus 2 do? Right? 2. And what about that minus 3? Down 3. So wouldn't you agree that my vertex is at 2, negative 3? Because my point 0, 0 reflected, didn't change. Right 2, down 3. That's my vertex, which means there must be a mirror point here. And again, if you're having trouble with the transformations, what can you do? Plug in numbers and get the y values. Just make sure you do it carefully. I would cover up everything less than 1 here. Yeah. Okay. Is this a function? Yes. This is a function. Anytime where they overlap, I have an open and a close, so it's allowed. Is this continuous or discontinuous? Discontinuous. But is it okay to have a piecewise that is continuous? Yes, absolutely. What is the domain? Negative infinity to infinity. And what is the range? To 6. Good. Okay? All right, f of negative 5. Now, I want you to do this without using your graph. Okay? Because sometimes the points I ask you for are not going to be the pretty points you plotted on your graph. So instead, you've got to know how to use these equations. So negative 5 represents an x value, correct? Okay, you got to figure out which of these three domains negative 5 fits in. Does it fit in the first domain, the second, or the third? The first, because negative 5 is less than negative 3, right? So that's the equation I plug it into. So 3 times negative 5, negative 15 plus 8, negative 7. Okay? I'm going to stop there for now because I think we've gotten lots of practice with the plugging in, and I want to make sure we have time to pass out your homework.